we'll get going. So again, thank you all for joining today. My name is Beth Hayes. I am the Pueblo County Agriculture, Natural Resource, and Small Acreage Management Specialist on behalf of Colorado State University Extension. I have multiple presenters for you all today that all have different expertise and entomology research with grasshoppers and related insects with that. So this is more of a statewide look. It's not county by county. And again, if you miss part of this webinar, you lose connection, you have to go for some reason, no worries. This will be recorded and available on the Pueblo County YouTube channel next week. And you will get a recording link of that in your email, along with various handouts that our presenters are going to talk about today. So don't feel rushed that you will be missing anything. You'll have everything via your email next week if you miss that. We will be taking questions at the very end, so once all the presenters are done, you'll have the ability to chat with them. You can either raise your hand and I will unmute you, or you can use the chat button to ask your questions that way, and I will verbalize those for our presenters. If you do use the chat, if you want to ask one of them individually a specific question, please just write their name so we know who you're talking about specifically. If not, then I'll just open it up for any of the panelists to share the information based on your question. So with that, we just want to make sure that you all also know that CSU Extension is a is an equal opportunity provider. We don't discriminate on the basis of disability, and we're committed to providing reasonable accommodations. We also have our principles of community and our land acknowledgement, which are always able to Google and look up if you would like more information. So with that, I'm going to stop sharing my screen so you all can see our first presenter, Scott, and I will let Scott introduce himself. He is from the University of Wyoming, but he is a key player when it comes to the grasshopper world. And so Scott, I'll hand it off to you and we'll get rolling here.
Okay, thank you, Beth. I tried sharing my PowerPoint window. Is that appearing on everybody's screen?
Yes, we can see it.
Okay, that's my first slide. So thank you, Beth, for inviting me down. I don't know much, but I do know about grasshoppers. I've worked with them for a very long time. Started as an undergraduate field assistant back in 1990. And Wyoming has lots of problems with grasshoppers, and that's why I started working with them because we had experts that were at the university, and I got a chance to learn from them. So I'm happy to try to help with Colorado's situation. Let's see if I can get there to go. It's the standard. I'm not endorsing products if I name them. One thing about grasshoppers, and probably a kind of a problem, is that we lump them all together. There's many species of grasshoppers, but one thing about them is they're ubiquitous, and they are the major above ground herbivore in the grassland biome. When you think of the grassland, you think of maybe cattle or bison, but on every square yard of rangeland, grass, pasture, any area that is not cultivated, you're probably going to find grasshopper, at least one or two. So sometimes people are kind of skeptical about that. Well, grasshoppers typically eat green vegetation equaling their weight daily. And many of the species will actually clip more leaves than they eat. Some of them walk up to a blade of grass on the ground, cut it off, eat what they want, drop the rest. We think, well, they're tiny. How does that matter? Well, if we look at the clearwing grasshopper, a very common pest species in the high mountain meadows, irrigated pastures in the western U.S., an adult clearwing female picture there to the right is only a fraction of a pound, very small, and the males are smaller, but 30 of them as adults is about 100 pounds of grasshopper per acre. So they're eating about 100 pounds of green forage daily. And if we put what a typical range cow would consume, which would be ideally about 2.5% of her body weight a day in dry matter, which that takes about 90 pounds of green forage to give her that much. So per day off of the acres that she will need to support her during the same grazing season. So again, grasshoppers are voracious, and certainly they are can be a problem. So that's how grasshopper management came into being. You might have heard of the Rocky Mountain locusts, which are a species of grasshopper that were extremely damaging to the early pioneers, mass invasions of them. And so that's kind of where the grasshopper management came about, to try to control them as far as being a problem. So the University of Wyoming's motivation was to improve grasshopper management, was to reduce the cost of insecticide and application when necessary, and keep the amount of forage loss to grasshoppers below the economic injury level for ranchers, while still reducing environmental hazard. So again, it's rangeland forage, unlike a crop where you have expected yield, and you know what the maybe perhaps the price per bushel or ton will be. We often think, well, rangeland forage isn't worth much on a per acre basis. Well, it's worth a lot if you cannot replace it and you depend on it to feed your animals. So that's certainly one thing to keep in mind. Grasshoppers, even in Wyoming, where we have some areas that are frequently infested, are not present every year. But once they start up, they can be a problem for multiple years. So this is just a picture of grasshopper hatchlings that are quite numerous. So you need, if you're having problems with grasshoppers, then you kind of come to the point, well, do I need to treat them? Do I need to manage them? And again, like I said, the economic injury level in some cases is kind of fuzzy. If you have a spare pasture, maybe your neighbor's not using pasture, how often does that occur? Or the hay is really cheap that year, maybe you don't need to treat, you can just get by. But for rangeland, at least in Wyoming and Montana, where we have typical northern grass mixed prairie in the areas that have grasshopper problems, studies have shown about 14 grasshoppers, the kind that feed on grass. Surprisingly, there are some that are not grass feeders. Per square yard will cause about a 30% forage loss by the end of the growing season on that northern mixed grass prairie with average precipitation. If you have a dry year, remember your production goes down, the grasshopper consumption stays the same. So it might be approaching 50%. And a lot of rangeland is stocked at a rate with livestock to consume 50% and leave the other 50% for wildlife, and also to maintain the physiological health of the perennial grass that's growing on that pasture. Now, we created, we called it a square foot job aid because we made it the size that's needed for a visual estimation of grasshopper density, because the first step that you need to do if you're thinking you have a problem with grasshoppers is figure out, well, how many do I have on my pasture, my range, my fields, and so then you need to estimate their density. And so that's a step one. In some cases, I know Beth was out last summer helping trying to establish, what the population densities were. So CSU Extension, some cases, the Colorado Department of Ag might be able to provide some help, and the United States Department of Agriculture, Animal Plant Health Inspection Service, Plant Protection and Quarantine, the grasshopper folks from USDA may be able to help you with this. But if you're like me, you like to be independent. So that's where this square foot job aid comes in. It is trying to provide everything that you need to know initially to help you make your decision on grasshopper management. I mentioned the APHIS PPQ. They have a long history. It goes back when the federal government first got involved with grasshopper control after the Rocky Mountain locust disasters in the 1870s. the so because grasshopper outbreaks can occur that cross political boundaries and are very extensive, that's how they historically they became involved. But they still maintain surveys to try to give warning to people as far as how bad grasshopper populations might be and how damaging they can be. So this is a 2023 survey over here on the left. The red is not good. That's 15 or more grasshoppers per square yard. They don't go higher than that. They could be 60 per square yard, but it's 15 or more. And you can see in the 2024, this fall or late summer's survey, there was a lot of grasshoppers out there at high densities. So that's alarming because part of this is a hazard based on the idea that if you have lots of grasshoppers laying eggs, then the potential for an outbreak next year is pretty high. So how large is the infestation? This is also important because if this is an infestation over your entire ranch, then you're in trouble. If it's localized, that gives you different options. If this extends past your boundaries and on your neighbor's boundaries, you need to communicate with them, because in some cases, if it's really large and you work together, you can get economy of scale as far as getting treatments done. Then not being independent. So I'd like to be independent in some situations, but working together can be advantageous in other situations, especially with large grasshopper outbreaks. So then the next step is to collect grasshopper samples, because grasshoppers are not all the same. Some are more damaging than others. There are a few species that are actually beneficial. and so we recommend you collect grasshoppers. Now, this square foot job aid was done back a while ago. BioClip is now out of business as far as getting SweetNet, but there are other sources of them. And you can actually get online. There's a few short videos that were done quite a long time ago now. They're kind of painful to watch because I'm in them. But collecting samples of grasshoppers are a necessary step. So you can figure out, well, what are your treatment options? Are these pests? Are they really bad pests? So that's why you got to do that. The other thing about examining them after you've caught them is you need to determine what stage they're at. And so this is a nice illustration of the complete life cycle of the big-headed grasshopper, which is, I saw data from your state. Do you have problems with this particular one in some areas? Usually associate them with bunch grasses, and they are also very fond of the intermediate wheatgrass and crested wheatgrass pastures. Can be extremely abundant there, and they're very damaging because they're a clipper. They not only feed on the grasses, they'll clip off more than they eat. So they spend the winter as eggs, hatch in the early spring, and they come out in as nymphs, looking like the adult, only smaller, without functional wings, and they have to molt in order to grow. And molting usually occurs. They're very vulnerable at that time. A lot of people, even though they've probably seen millions of grasshoppers in their life, have never seen one molting. But this is a critical piece of information, because I think the best product that we have to treat grasshoppers interferes with the molting process. So you have to treat them while they're early instar. So this is why you need to determine what life stage they're at. Ideally, you want to catch them early before they've done a lot of damage, and then they're also vulnerable to this situation. You don't want to wait until they're putting eggs in the ground for the next year. Now, when you're out in your pastures this spring, you might see some grasshoppers that are already adults or already pretty big. There's actually some that overwinter as nymphs above ground, and they become active very early in the spring. Pretty amazing when you think how harsh the winters can be. And then there's also some species, that require 2 years to in the ground to come out. And so this is one that's not real common and is not a pest in our region. It can be a pest in Mexico, cotton and some other crops, but the plains lever grasshopper is just an example of variation. That's when you're talking about insects, you always have to say that there can be variation, because that's one of the things that it makes them so interesting to me. So what kind they are. There is some information on the square foot job aid about that and why it's important. There we go. And so this is, like I said, one of the important things about it is you want to make sure that, say, if you've got a lot of broom snakeweed on your range and you have a grasshopper that likes to eat that particular plant, maybe that is making up a majority of the grasshoppers out there, and so you don't really need to worry about it because they're actually doing you a favor. Conversely, some of them are very bad as far as they consume a lot of the good forage. There are some that only eat grasses, would starve if they were next to a field of broadleaf crop plants. Some of them only eat cool season grasses, and some of them primarily only eat warm season grasses. So again, the grasshoppers, some of them can be very damaging if they move into trees and shrubs. This is a picture. My friend in Nebraska has a small orchard he was trying to grow in central Nebraska, and grasshoppers came in and were very damaging to his fruit trees. Grasshoppers can also be scavengers, and we have done research to take advantage of that because they like to eat dead grasshoppers to accumulate an essential fatty acid that is they have to get it through their diet. And so a squished grasshopper is a good snack for another grasshopper. And in some cases, they're just scavenging stuff off the ground, whether it's dry plant material or manure, those types of things. So again, grasshoppers eat a lot of different stuff, and it can be important to know what you are dealing with. This particular grasshopper here is one that likes cool season grasses. This is the Amphitornis coloradensis, and then about a dozen species are major pests. There are other grass feeders out in assemblages that can contribute to forage loss, but often there's just one or two species that are in an outbreak that dominate. So here's another one. This is Opia obscura. This is a slant face grasshopper. Both of these are in the subfamily Gomphocerinae, slant faces, or sometimes they have big heads in proportion to their bodies. They eat warm season grasses, so they hatch very late in the season when the warm season grasses are going. I think in southern Colorado, where you get some of that monsoonal moisture and can have a green up of say buffalo grass or grama grasses late in the summer, this would be one that could be a problem. And then here's a particular one that likes to eat broom snakeweed that can be considered beneficial. So you can there's some information on YouTube about species eating grasshoppers at University of Wyoming Extension's YouTube channel. And then, of course, you can also get help from your Colorado Department of Ag, CSU Extension, or APHIS in some situations. Here's just a picture of a display that we've made up and given our county weed and pest offices to help them help their customers in the state. Again, if you really get into grasshoppers, there's Professor Fott, who was a longtime professor at the University of Wyoming. At the end of his career, he put together a great publication on western grasshoppers, and most of the content is available online. Unfortunately, right now, the link at UW, the pictures were broken at the last change of the content management system. So again, you can just search for Professor Fott, a very unique last name, Western Grasshoppers third edition, if you want to learn more about them in particular. Another reason why it's important to know what you're dealing with is grasshopper behavior. Now, most grasshoppers live and die in the vicinity where they hatch, but some of the major pests can move fairly long distances, even as nymphs. So this is the clear-winged grasshopper, their first instar, very distinctly marked. After they've eaten all the grass in the area where they hatch, they can start marching, and they'll march in mass and go several miles to find food. Other species, once they reach adulthood, can fly long distances. Now, the Rocky Mountain locust, which was a relative of this particular one called the migratory grasshopper, was famous for flying long distances. This one has been documented flying over 100 miles a day. This is the migratory grasshopper, Melanopus sanguinipus. They are also prolific and have been documented increasing from around 3 per square yard to more than 30 per square yard in 1 year. So from one spring to the next, you would have that increase. And so certainly they can be damaging. They're also an omnivores in such that they eat both grasses and forbs and broadleaf plants, so problems. Here's an interesting picture from where a swarm of migratory grasshoppers that were flying up in Montana. They picked a bad spot to land. They landed on Fort Peck Reservoir. So again, we do not have any grasshoppers in the United States that are considered locusts, but the migratory grasshopper is pretty darn close. A little bit about grasshopper ecology. I was talking about, it's very unusual to find a spot that doesn't have multiple species. Usually you have anywhere from 5 to 20 species present, and because they have all these niches that they fill, again, that's the part of the reason you see that. But in some cases, you do have outbreaks of these particular species. But in Wyoming, most years in most areas, grasshopper population is much less than 8 grasshoppers per square yard. And sometimes, probably less than 3 is the dominant density on our rangeland. Grasshoppers are prey for many generalist arthropod predators, such as robber flies here with a grasshopper nymph, or wolf spiders. There's also, they're attacked by specialists that go after, like certain stage, like their eggs. So bombilid or bee flies, they will lay eggs in areas where grasshopper egg pods are being deposited, and then the maggots will crawl down and dig into the egg pods and then develop over the course of the season, and then emerge the next year as the adult stage. Blister beetles are, you can kind of consider them our ally. Usually their populations track grasshopper populations. The ones in the genus Epicata, like this black blister beetle. There's also gray species and striped species that utilize grasshopper egg pods. They are problematic because they also have the behavior of swarming on flowering plants, and in particular alfalfa, if it's allowed to flower, and then being accidentally incorporated into alfalfa hay. Blister beetles get that name from having a blistering agent in their blood as a defensive mechanism. And unfortunately, that blistering agent is very toxic to livestock. There are also even smaller things that attack eggs, such as this tiny little coelioid wasp. And there are also mites. You might have seen, if you've looked at many grasshoppers, you sometimes see little red things. And if you look very closely, there are little red mites that are kind of like grasshopper ticks. And they also have a stage that will attack eggs. So there's many things. Grasshoppers are also food for non-arthropods. If the nymphs are abundant, they're an important component in the early diet of sage-grouse chicks, or for many rangeland songbird species, nestlings. But in many years, like I said, in Wyoming, the grasshoppers, if they're abundant, they're taken advantage of. If not, they utilize other insect protein. Grasshoppers can also be a detriment to other wildlife because of their consumption. Here, the migratory grasshopper, took a picture of it a long time ago. You can see I was a great photographer back then. That was defoliating silver sagebrush in an area of Platte County, Wyoming. And silver sagebrush and other sages and shrubs can be a very important winter browse for big game animals. Actually, on the National Elk Refuge in Jackson Hole in 2010, the APHIS conducted clearwing grasshopper management because they were devastating the forage that they tried to grow for the elk on the refuge. And in case they also had problems with them depleting the critical winter game range forage for elk on the Bighorn Mountains on the West Slope in 2010. So in outbreaks, a lot of times you get predator saturation. Here's a big wolf spider just surrounded by perfectly suitable prey for a spider head size. It can't eat any, it's just saturated. Grasshopper control really is not about killing grasshoppers. It's about protecting the forage that you need for your livestock. So in this case, here's some evidence that grasshopper control can do that. I communicated with a couple of ranches, the Owen and Kimsey ranches in 2010 when there was big grasshopper outbreaks. They had some areas that they didn't treat. Either they felt they couldn't afford it or for other reasons were untreated for grasshoppers. Others were treated, but they were primarily for winter range for their flock or herd. And so on the Owen Ranch, the site that was treated when I went in to sample the vegetation in early September, they unfortunately had to bring their sheep on about 3 weeks before I sampled. So there had been some grazing going on. It still exceeded the amount that was untreated and was ungrazed by anything other than wildlife and grasshoppers. And then you can see here on the Kimsey Ranch, it was quite a bit more forage left behind. This is the dry weight of the forage compared to the untreated, ungrazed area. So that's what we're aiming for. It's not, if the grasshoppers, didn't eat the forage, we could ignore them, but that's why they're a problem. So what do you do about them? Well, at the University of Wyoming, we started work on it in the 1990s, early 1990s. And before that, synthetic insecticides applied at a blanket rate at a high rate to try to pretty much kill every grasshopper possible with the idea, well, if you leave any behind, they're going to come back. Well, that's probably, knee-jerk reaction, oh yeah, it's a good idea. But it turned out that rats is a better idea. We actually take advantage of some things about the grasshoppers. We leave some behind as a prey base for their natural predators, and we utilize the lowest rate possible of the chemicals registered for rangeland treatments. And those are ones that can be applied over grazing animals. They have 0-day grazing restrictions, so you can actually treat over the top of them and do it this way. It was kind of a schematic here as a blanket treatment. This is a rats treatment. So that's reduced area agent treatments. We had to come up with a clever acronym. The rats concept's pretty simple. Grasshopper nymphs are killed directly in the treated swaths. More predaceous insects and parasitoids survive the treatments. Pest grasshopper nymphs will move. They move a lot. Others, like the species that's a beneficial weed eater, once they've found a patch of the weeds, they really don't move around as much as the forage eating grasshoppers. Of course, other things that prey on the grasshoppers keep on preying on them. And there's also less disruption to biocontrol agents of weeds, noxious weeds. There's actually some data on testing that they did on the beetles that are used against leafy spurge in Montana. So again, we are protecting forage is the goal, and we do not want grasshopper extermination. They couldn't get it done even back when they were using extremely potent insecticides on the rangeland, and now we do not want to do it. So what kind of control do you get? So the three types of insecticides that are still labeled for this usage, whoops, twitchy, are carbaryl, malathion, and diflubenzuron. And I'll talk a little bit more about the one that I think is the best. So you do after 21 days with the rats method, you would get a little less control with each one of these insecticides, but it's still adequate control because of the nature of the grasshoppers. Remember, you're talking about rangeland. It doesn't have an extreme value per acre, and it's so you've got, I tell people, yeah, you can kill them all and you can kill them all fast, but you can't afford to do it, and it's not wise to do it. So this is just a schematic. So in Wyoming, what the most common treatment has been used since the early 2000s on grasshopper outbreaks is 1 fluid ounce of the diflubenzuron insecticide, and that would be either Dimlin 2L, which is the original product, or there's now some generic equivalents, mixed with at least 8 ounces of water and at least 4 ounces of an oil adjuvant, applied with, depends on the size of the spray plane, 100-foot to 135-foot wide swaths are most common. And so this is also an advantage because when you think about, if you have to treat large areas, so essentially the plane treats one half of it, but protects the whole thing. So it turns a smaller spray plane into a big spray plane that allows economical treatment. A little bit more about diflubenzuron, and you probably maybe not familiar with it. It's actually been around since the early 70s, but it hasn't gotten the grasshopper labeling until the early 2000s. So it is a insect growth regulator class, and so I guess killing them is regulating their growth, but it interferes with a growth process. It's not like a neurotoxin. It interferes with chitin, which is a component of their exoskeleton. Arthropods have that. Other things like mammals and birds and fish, we do not have chitin or chitin synthesis. So it is labeled for now rangeland and pasture, 0-day grazing restriction, and a few crops like alfalfa and some small grains. It has a long residual at its highest label rate, and about 21 days at the 1 ounce rate. It can be longer. It depends on some situations, but that's what we usually figured it at. It has lower impact on non-targets and arthropods because it has no contact activity. You put it on the vegetation, and then the insects that eat those leaves will accumulate it, and if they're going to molt, it will interfere with that process. So this is how a grasshopper looks like on a normal molting process. Here's the old exoskeleton. It's using gravity to help get out of it. After an unsuccessful molt with diflubenzuron, this is what it looks like. So you don't see a lot of dead grasshoppers or other insects laying around on the ground after a Dimlin treatment. The grasshoppers just slowly fade as exposed, treated grasshoppers molt. And they do that usually secretively, so it's hard to find them out in the field. So again, it's a different type of chemistry. So I talked about, it's lower risk. So for mammals, let's compare them with the 3 most common chemicals to mammals, where they used rats for testing. LD50 is the lethal dose for 50% of your test animals. So you can see here the malathion is relatively non-toxic. This is direct application for ingestion. Carbaryl is also, it's more toxic, but it's still widely used. And then you get diflubenzuron, and it's at the level about the same amount. If you force-fed rats table salt, it would be about the same. So then if you just look at if it gets on the skin of the creatures, again, diflubenzuron is much less toxic. This is in milligrams per kilogram. So a kilogram is about 2.2 pounds, and a milligram is 1,000th of a gram. So how about hazard game birds? Well, if you look at that, utilizing, I think these were pheasants or quail were the test subjects. LD50, again, diflubenzuron is much less toxic than the other two older products for grassland grasshopper control. And then if you apply them at the labeled dose rates, the area of 1 square foot receives 5.3 milligrams of malathion, 2.3 milligrams of carbaryl, and 0.16 milligrams of diflubenzuron. So to pick up a lethal dose, a 2.25 pound bird would have to consume all of the pesticide applied to 32 square foot with the malathion, 900 square feet with carbaryl, and about a half an acre with diflubenzuron. So very low toxicity, and most of our game birds are not eating the leaf surface. And then, of course, some of the product falls on the soil, so it's not going to be available to them anyway. Hazard to fish. Now, diflubenzuron actually has veterinary usage in that you can take koi carp that have anchor worm, which is not really a worm, but an arthropod, and you can put them in a saturated solution of diflubenzuron and let them swim around for a while and take them out and put them back in their pond. And it doesn't seem to hurt the fish, but it kills the anchorworm parasite. So essentially, compared to malathion and carbaryl, which are neurotoxins, the diflubenzuron is pretty much non-toxic. How about other insects? How about beneficial insects? Well, you don't see a lot of honeybees foraging on typical rangeland, but honeybees are certainly a concern and can be a concern around cropland and other places like that. So when diflubenzuron was first brought out, it was utilized for citrus pests, and they did some testing of treatments at much higher application rates, much more frequently over beehives in orchards, what Schroeder did in 1977. They found at the end of the season no difference in brood numbers between treated and untreated hives, and no detectable diflubenzuron residues in the honey. When they started using it in cotton pest control, they did a similar test in 1979, 8 consecutive applications at a lower rate, 1-week intervals over the beehives placed in the fields. Again, no difference in treated and untreated brood ratio, no change in brood development rate, and no detectable residues in the diflubenzuron and wax pollen or honey. Because essentially where the bees are foraging at inside the flower is not going to be a place where the diflubenzuron gets. And then the way it's applied and the formulation, it goes on to the leaf surface and sticks, and so the bees are not eating the leaves. So again, very little hazard to the honeybees, and especially when you compare it to a grasshopper control, which would be a single application on rangeland for dimlin or diflubenzuron at about 7 grams of active ingredient per acre. So it reduces the hazard by 64 to 120 times. The additional reference about insecticides hazards to this is a good publication from Oregon State, which compares the insecticides that we have registered and their risk to honeybees and other bees, leafcutter bees, and those types of insects that are beneficial compared to all the different chemistries that are out there, including herbicides and fungicides. So that's a good publication if you're interested in that. So I heard Beth say we're going to wait on questions to the end, and so we'll just go ahead, and I think I'm doing okay on time. we'll just skip ahead. So Beth asked me to talk also on crop pest grasshopper IPM because it's a little bit different. Uh, we on rangeland, it's a natural system. On crop pests, essentially, you're dealing with ones that are moving in and damaging crops that are in your cultivated fields. These are the four probably predominant crop pest species in the western U.S. Migratory, the Melanopus sanguinipus, the differential, the two-striped, and red-legged. Now, they are very damaging, and the adult two-striped females get pretty big. And at 30 of them per square yard, which I've seen them at much higher densities, that's about 200 pounds of grasshoppers per acre. So that's kind of like if you have that many in your field, that's like having a voracious sheep that can eat its body weight daily. So essentially extremely damaging. Here's comparison to the typical clear-winged female. So, and it's recognized that the way they eat, they waste 6 times more leaf area than they actually consume. So our crop pest grasshoppers only have one generation per year. The eggs are laid in pods in the soil. They have preferences on where they like to lay their eggs, and that's part of the reason why those particular species are crop pests, because they can take advantage of the habitat that we create around the edges of our fields. So the egg pods, if they're laid in an area where it's going to get tilled, heavily tilled, then those will destroy those egg pods. But they usually lay them in association with the fence rows and borrow ditches that are adjacent to the fields. They can have anywhere from 1 to 4 egg pods per female. This relates on how bad their population might be from one year to the next. This is where this long, mild fall that we had is going to be probably lead to most all of the egg pods that were laid by females. If they got 3 or 4 out, they got their embryogenesis or development inside the egg to the point where they can survive the winter. So this is not a good thing in that I enjoyed the mild fall weather, but that's not a good thing. So again, those crop and garden pest species, if they're well fed, can have anywhere from 50 to over 100 eggs per pod. This is what a two-striped grasshopper egg pod looks like taken apart. So again, there's a pencil for scale, and you can see how tightly the eggs are packed in that pod. The pod material is almost kind of like that construction foam. It helps protect the eggs from the soil and microorganisms in the soil. But again, the grasshopper eggs density can be extremely high in those areas where they choose to put their eggs. Here's just another kind of schematic of a typical grasshopper life cycle. So you have the egg pod overwintering, and then they hatch out. One thing about them, grasshopper nymphs, when they first hatched out, they're tiny, and people are easily overlook them. It's also a critical stage for them because a lot of the mortality, especially due to weather events, can occur when they initially hatch. And so that's an important thing to keep in mind sometimes, especially in the past where you have shorter residual insecticides. You're reluctant to treat until you get more of them hatched out because you're wanting to make sure you get them all. With the diflubenzuron, that's not such a problem. Again, usually it depends on the weather and the food, how long it takes them to go from each stage. But anywhere probably from 5 to 7 days is a good average. Again, there are some species overwinters. The nymphs or crop pests are not that. And then adult life is anywhere from 50 to 60 days. The two-striped grasshopper is a hardy grasshopper. It takes a pretty hard frost to kill them. So I've seen them here in Laramie, which is 7,200 feet in elevation. About 2 weeks ago was last two-striped grasshopper that I saw. So that simple metamorphosis, again, about a week per instar. So if you go out and you see these things hatching, if you haven't done some pre-planning and preparation, it might take a while to get all of your things in a row to get a treatment done. So it's always good to start early. If you get out here and you see, oh my gosh, I've got a whole bunch of fifth instars, well, then you're going to get to the point you've already lost a lot of the forage they consume as they develop, and you might not be able to use diflubenzuron if they've already made it to the adult stage. It's because they're done molting. Now, this is probably the picture that show adults a lot of times, but the nymphs are the most important thing if you're going to control them, because they are where you can do the most good. You can prevent damage, prevent egg laying by the adults, and so treating the nymphs, recognizing them. When they first hatch out of the ground, they're only about the size of a long grain rice, and so even the larger species like the differential is not very big. These are all in the genus Melanoplus. They're all Melanopline. They have a spur in between their front legs, right behind their head. Spur throat is another common name for them. And I say they have the Nike swoosh, kind of. All of them do, especially the red-legged has a very defined swoosh. Where do they come from? In some cases, if you have the migratory grasshopper out on the range and that becomes depleted, they can move into your cropland. In other cases, and I'd say the majority of the cases with the other pest species, they come out of fence rows, borrow ditches, say the corners around irrigated circles that are not cultivated, and can infest your fields. That's a lot of times where you need to be watching for them. Now, these common crop pest species often lay their eggs in these untilled field borders. There has been some cases where no-till and minimum till fields where, say, they're only cultivated with implements like sweeps, which may go under the grasshopper eggs and not disrupt them enough to kill them, can allow them to survive and hatch inside a crop field. The vast majority of crops, if they are tilled or flood irrigated out in the field, that will kill grasshopper eggs too, of these particular species. But if you can get this non-crop area treated, you can protect the crop. That's my goal, is get them before they get in your crop and start causing yield loss. And then if they get in the crop, yeah, there's insecticides that you can use to treat them, but they're usually more expensive. And so essentially that's where doing scouting is very important. So to put it in perspective, at least for me, if you have say you have a 40-acre cornfield, and that's relatively small field by today's standards, but it's, say, a 40-acre irrigated cornfield, and you have a 15-foot border around it where you can turn your machinery around, or there's some area that you just can't cultivate easily. That's really like only having 38.2 acres of corn and 1.8 acres of grasshopper habitat. If you just have 200 grasshopper eggs per square yard in that habitat, in that border habitat, and they all hatch and survive and spread over the field, that's 9.5 grasshoppers per square yard. And it's Parker recognized in he's an early scientist on grasshoppers. 10 adult two-striped grasshoppers per square yard can defoliate a knee-high corn crop. So it would be almost total loss if nothing is done. What would I do to protect my field? Well, there's a lot of small application equipment out there. A lot of it is designed for treating weeds. And we found that you could adapt it and use it to treat those fence rows and borrow ditches and things like that with ATV or now UTV or spray buggies with applications of Dimlin. And I would use it at the label maximum rate and apply with the application volume that matches your equipment and adjuvant that is suitable for the plant cover. So again, this is showing the back end of an ATV spray rig. Has a boomless nozzle, they're called, just spraying one direction. So the kind of coverage that would easily treat those border areas. Now, the Dimlin 2L and the generic equivalents are restricted use pesticides. So you've got time to get or maintain your pesticide applicator license in order to be able to apply it, and you follow the label to the letter for non-crop area. Non-crop restrictions for that, it says see grassland section for that. And so essentially it's 2 fluid ounces per treatment and not to exceed 6 fluid ounces per acre. Now, most of the time you probably only need to treat once, but on some of these grasshoppers, like the crop pest species, you can have an extended hatch. That's a lot of times also gets people into trouble. Say they see grasshoppers hatching and they treat once and think, I got that done, I can go on to the next thing. And 3 weeks later, they've got grasshoppers crawling all over the place because subsequent hatches have occurred. So again, your goal is to keep them out of the crop. And so it has a long residual, but keep in mind that as broadleaf weeds and other plants in those fence rows and bar ditches grow, the new leaves coming out the top of the plant are untreated. And that's where grasshoppers like to roost and eat. So again, this is something to keep in mind. You may have to treat more than once, especially if you're using something without the long residual of diflubenzuron. If you're using carbaryl, you're definitely going to have to keep an eye on it and maybe treat multiple times. If you're applying baits also, that baits generally weather out of the field, even if if nothing eats them, wind, rain, all those types of things, other ants, darkling beetles will consume baits. So again, scouting that and applying that targeted to that area is going to help you prevent damage in your crop. So that good timing is very important. Trying to get them early. I tell people I've never seen it really applied too early. I've seen it applied too late, but never too early. What are the other options if you can't, for some reason, use Dimlin or generics? There are pyrethroid insecticides that also have suitable labeling for that non-crop area. So they will work low. They have low mammalian toxicity, fast knockdown. They work on adult grasshoppers. Many of them have broad crop labeling, so it's safe to apply it next to your crop. A wide temperature range of application. They are broad spectrum, and they are a neurotoxin, and they have shorter residual activities are the cons. Carbaryl, very familiar product, been around a long time. It is also a neurotoxin. It is reliable results, has a decent residual at the highest rates. A familiar product, easy handling. Again, broad spectrum. It will has contact activity, so insects that crawl onto the plant or have other exposure will be killed. Potential harm to people because it is a neurotoxin, and this particular one sometimes has a suppression of the acetylcholine esterase levels in people that have been exposed to it a lot. You can also utilize baits. Brand that has been treated with carbaryl or pelleted baits are available. They are also labeled for these non-crop areas and homesteads. They will kill adult grasshoppers if the label maximum rates are used, but they're better aimed at the nymphs. So, and multiple applications of the baits will be necessary because, like I said, they don't last all that long. So you need to treat through the entire hatching period in order to get good control. Small area applications besides the spraying for applying baits. They do make some equipment. Unfortunately, Peacock Industries no longer makes a brand bait spreader, but I think there are some other companies that have stepped up. And there's also for the pelletized type, herbs spreaders are often utilized. uh, uh, for applying the baits. So I'm often asked, what's my forecast for the grasshopper problems and stuff like that. And I feel kind of like a weatherman, where I always go with a 50% chance, so I have at least a decent shot of being right. But yeah, so I would say if you had a lot of adult grasshoppers, and we had a mild fall and they weren't starving and they were putting a lot of egg pods in the ground. Even if you have high mortality in the spring due to natural causes on them, you may still be dealing with high populations this coming year in 2025. I, I hope I'm wrong, but it's best to prepare and get ready for them in case they are back. So now we can switch and get some questions if you'd like.
Due to time, I know there's a lot of questions and there's a lot of folks that want to ask things, but I promise we will get through most of them. I have been also recording all of your questions, so we're going to switch presenters. Thank you, Dr. Shell, but we will get to the questions that I've seen in the chat, and we'll do those at the end. So again, if you missed some of it, don't worry, it's been recorded. Dr. Shell has given a lot of good information here. It will all be available in your email as well. So don't worry if you couldn't copy everything he said. I promise you, you will have access to all of those documentation. So with that, Dr. Shell, you can stop screen sharing and we'll hand it over to Kareem. And then we'll just keep going down the line and then we'll have time for questions. Perfect. Thank you.
Great. Can everyone see and hear my slides? At least hear
Yes.
me?
Yes, we
Cool.
can hear, see you, and see your slides.
All right, I'll just get into it. So hi, everyone. My name is Kareem. I'm probably the most junior entomologist here. I work for Denver County Extension, and I also do love insects. Behind me are my pet tarantulas. Probably can't see them. But anyways, we're going to focus on grasshopper management for the urban gardener. So this is going to apply more to, more backyard gardeners, master gardeners. Oops. All right, so why are we talking about this? So Dr. Shell showed you a map of like some of the previous grasshopper forecasts. This is all the grasshopper forecasts from the USDA starting from 2016 going until 2024. As you can tell, the situation is kind of getting worse. The red areas are the highest concentration, orange is the second highest, green is behind that, and then blue is like the lowest concentration. So don't shoot the messenger, but the issue is getting worse over time. You can blame this mostly on climate change. The main feature used to create these maps is the number of degree days, the number of days above a certain temperature. And with climate change, because things are getting, we're having warmer days towards the end of fall, and it's getting warmer earlier in the spring. The plants that the grasshoppers depend on for food are coming out of dormancy sooner, and they're going into dormancy later. And that corresponds to the grasshoppers also going into dormancy later, coming out of dormancy sooner. So we can expect it to get worse next year in the coming years, but yeah, it'll depend a lot on the weather conditions that we'll have over this coming winter and spring. I want to talk a bit about grasshopper biology. So grasshoppers, as you probably know, they undergo incomplete metamorphosis. The babies are just smaller versions of the adults. This video that I'm playing shows their egg-laying behavior. They lay their eggs in soil, and their abdomen actually has two sharp appendages on the end that are for digging. They literally dig into the soil, which you can kind of see happening here. And their abdomen is also very extendable. If you saw that graphic that Dr. Shell showed you, where it looked like the grasshopper abdomen was tripled in length, that's not really an exaggeration. They can drastically extend their abdomen. And there's a little fly trying to get in on the gelatinous matrix of goo that's going to be laid there. And they also have cyclical population explosion. So they're usually a big problem one year, not as much of a problem the next year. But again, with climate change, that baseline for what's a low level of grasshoppers, that's also going to shift up. So I can't say for certain, what's going to be, if they're going to be a huge problem or a small problem next year, but regardless, they're going to be a bigger problem than they were in previous years. Grasshoppers also have ears. They have something called the tympanum or the tympanal membrane. It's on their abdomen, and it's a membrane that is very sensitive to vibrations. Just a really fun fact. This is not really relevant to management. Grasshoppers also have a defense mechanism where they can throw up on you, essentially. If you've ever picked up grasshoppers and harassed them, as I often do, They can regurgitate plant material, and it's like this very viscous, dark material. I've heard that it smells like chewing tobacco, and it's not toxic to you. It can't really, hurt you. I've got it on my hands, and it's been fine. But it is enough to deter a lot of predators. Another really useful tool for identifying grasshoppers is iNaturalist. So this is a citizen science tool for documenting different species for all organisms, not just insects or grasshoppers, based on pictures. And I mention this because, there's a huge diversity of grasshoppers. We have, as you can see here, more than 100 that have been documented in Colorado alone. And a lot of them have dietary preferences. Some grasshoppers prefer to go after, grasses. Some prefer broadleaf plants. So if you see a grasshopper, like a lot of one species, you don't know what it is, snap a picture, upload it to the app or the website, and maybe you'll be able to figure out if it's going to be going after, your ornamentals or just the local weeds in the area. All right, so now we're going to get into the meat of today, IPM. How do we manage grasshoppers as urban gardeners? IPM stands for Integrated Pest Management. And this pyramid to the right here describes the different types of pest control strategies involved in IPM and how they vary with respect to risk and labor, whether they're more proactive or reactive. Things towards the bottom of the pyramid are much more proactive, more preventative, and things towards the top are much more reactive, much more interventive. And whenever possible, we want to use the measures towards the bottom of the pyramid. And the reason for that is that, like think of this pyramid as like if I'm fighting a wildfire. Things towards the bottom of the pyramid are like doing controlled burns, making sure that I have, well-spaced, healthy trees that aren't as likely to burn. Things towards the top are like just dumping water on a fire. What makes more sense to you in the long term? The more proactive, preventative measures. I will say though, grasshoppers, they're very prevalent and they're very mobile, and that can complicate control. It's kind of like how difficult it is to manage Japanese beetle in the Front Range. They're everywhere and they can fly. So the second that you stop implementing control measures on your little backyard garden, they're going to reinvade from neighboring areas. So just keep that in mind. All right, let's start with cultural controls. The main thing that you can do to prevent grasshopper infestations is to not plant things they like, or plant things that they like intentionally, but do it strategically. So grasshoppers, like us, they have favorite foods. Some of those favorite foods are listed here: lettuce, onion, leeks. They really like green and fleshy plants. And you can intentionally plant those plants to essentially consolidate the grasshoppers. Instead of them going after your plants of interest, they'll attack these trap crops, and then you can just treat those trap crops, just bag and net the grasshoppers on those trap crops instead of having to go and pick them out from throughout your garden. Some considerations when you're placing or planting trap crops. If you live near like a local natural area, like a local open space, a grassland, try to plant your trap crops between your plants of interest and the direction the grasshoppers are coming from, which is usually going to be one of those natural areas. Think of it as like a little barrier or a moat. Two other considerations though. If you're going to use trap cropping and you're seeing the grasshoppers are consolidating themselves, you don't want to let your trap crop ever dry out, or you don't want to ever mow it. Both of those things will cause a mass exodus of the grasshoppers off of the trap crop onto the plants that you actually like. Physical controls, you can hand pick the grasshoppers. You can get a big bucket of water, add a drop of soap to it so that the grasshoppers don't float as easily and they'll fall and they'll drown and go to hell where they belong. You can also till. Tilling the soil will it'll expose the eggs that are laid underground to adverse weather conditions as well as predators and parasites. Tillage is a bit of a double-edged sword because yes, it is effective for managing a lot of insects that overwinter in the soil, but it also destroys soil aggregates. So, over time, healthy soil develops into these clumps, and tillage will essentially reset those clumps. So you kind of have to balance what is the grasshopper pest pressure and the health of my soil. Also, you can use physical barriers. So netting and row covers will just physically keep the grasshoppers away from your plants. But keep in mind that grasshoppers have been known to chew through plastic nettings when there is a high enough grasshopper pressure. So sometimes even like a metal netting is required in extreme situations. For biological controls, there's plenty of animals that are naturally occurring in the environment that will attack grasshoppers, such as Dr. shell-covered blister beetles, as well as some other insects like bee flies, robber flies. Coyotes are also known to eat grasshoppers, but I wouldn't really depend on any of these things as like an effective long-term control. They're going to eat some, but they're not going to get rid of the problem entirely for you. Plenty of birds also eat grasshoppers. Horned larks, which are a native bird here in Colorado, eat grasshoppers, as well as chickens and guinea fowls. I've heard some stories from people in Pueblo, which is seems to be the most severely affected by grasshoppers of area in Colorado. People having really good success using guinea fowl. The only caveat is that both chickens and guinea fowl will scratch up the soil in their search for insects, and they can damage the roots of plants in their quest for grasshoppers. And then I think an underutilized biocontrol are weird kids. Just getting the neighborhood kids to get a bucket of water and do that physical control for you. Kids who aren't scared of insects can be a really effective workforce. That was definitely me as a child. Now, there are commercially available biocontrols. So starting with the entomopathogenic fungi, and by the way, this big fancy term, entomopathogenic, it just means spreads from bug to bug like a disease. So there is Nosema lacustae, which is probably the most popular nolobate. I'm not going to go too in depth here because Melissa is going to cover nolobate a bit more in depth. But this was so popular because it is a fungus that is very host specific. It only goes after, I think, members of the Orthoptera, so mostly grasshoppers. It doesn't attack, the beetles and the butterflies. It doesn't attack any other, like animals, like worms and fish, but it doesn't even attack other insects. It's commercially available as something called nolobate, but it's been hard to get your hands on Nosema locusta in recent years because as I'll cover in another slide, our local producer hasn't resumed operation, the one in Colorado. There are two other entomopathogenic fungi that also attack grasshoppers, as well as they're much more generalist. They attack a diversity of insects. Bavaria bassiana, called white muscadine disease, and Metarhizium anisopliae, green muscadine disease. They're both so named for the color of the spores they produce in their infected hosts. As you're seeing on the top, this is the green muscadine. On the bottom right is the white muscadine. Like I said, they're generalists. So they will go after grasshoppers. They will also go after any other insect that they encounter. And then you also have the option of entomopathogenic nematodes, so microscopic worms that'll also infect grasshoppers. Steinernema and Heterorhabdites are both commercially available. Both these nematodes have a cool mutualistic relationship with bacteria. So they house bacteria in their bodies, and once they infest an insect, they will expel those bacteria. And then the nematodes and the bacteria go to work essentially double teaming. They tag team the host because bugs have immune systems and they can fight off the worm by itself or the bacteria by itself, but not when they're getting double teamed. And a question that is often posed to us extension agents is, can I use like praying mantises and buy them and use them as biocontrol? Praying mantises will eat, grasshoppers occasionally, but it's like Dr. Shell mentioned earlier, there is such a thing as predator saturation. The mantids will get full, or they're going to attack more than just grasshoppers. They're going to eat whatever they can find. So there's no guarantee that they're going to restrict their diet just to grasshoppers. So I wouldn't really look to them as some saving grace. They're not going to get rid of your problem for you. Maybe they'll help a little bit. So the reason that we are, there's a lack of nolobate in Colorado is because the facility in Durango that produced this fungus burned down in 2018, and it has yet to resume operation. So there are some other organizations, companies that are producing nolobate. So you can definitely buy it from outside Colorado. I would just say whenever you're going to buy any of these biocontrol agents, you want to try to purchase them from as close to you as possible, because the longer they spend in transit, the more are going to die in transit, and that reduces the quality of what you receive. And let's see how I am on time. So someone mentioned in the chat, I'm going to give you a trigger warning. You're going to see a video of worms emerging from an insect, so fair warning. You can just listen to my soothing voice describe it as well. So there is a parasite called horsehair worms, a type of nematode that will infect, I think, a huge diversity of insects, not just the Orthoptera. So more than just crickets and grasshoppers, it's even known to go after mantids. It has a really cool behavior where it infects these insects and then makes them seek out water, because the worm will emerge from the insect once it's in the water, and that's when it'll breed. So it's a cool kind of neuroparasitology of mind control, because normally these insects would never go anywhere near water. They can drown very easily. This is also not like a really effective, it's not going to be like a permanent, it's not going to control the grasshoppers by themselves. It's good, and it'll help along with all the other things attacking grasshoppers, like the horned larks and the birds. But I wouldn't look to this as, again, like, it's not your saving grace. It's just one cog in a bigger machine. Let's see. I always struggle to get out of the video view. Whoops. Okay. Oh, sorry, y'all. Give me just 1 second here. Okay, there we go. From current slide. And I'm about to wrap up here. My presentation and also as well as Melissa and Lisa's are going to be much shorter because we're just kind of covering the surface. All right, so insecticides. This is all pulled straight from CSU's fact sheet on grasshopper management. There are several insecticides to manage grasshoppers, such as carbaryl, which is available as like a brand bait. These brand baits are really only effective when applied very early in the season, like the very early spring, to kind of hamper grasshopper populations before they balloon into this massive problem. Um, and if you're not familiar with baits, essentially it's a bait that is laced with the insecticide, and this is better than applying a spray because there's a smaller amount of insecticide in there, and so the grasshoppers are attracted to it. They consume that smaller amount, and then they eventually go off and die. Instead of spraying a chemical that's going to be broadcast over the whole system, and it's going to affect all these non-target impacts. The brand system definitely reduces our non-target impacts. Other insecticides used to manage grasshoppers are acephate, that goes under the trade name orthene, or like Dr. Shell mentioned, diflubenzuron, which is trade name Dimilin. One thing I forget if Dr. Shell mentioned this, but Dimilin, diflubenzuron, because it is a chitin synthesis inhibitor that affects how insects molt, it is not going to really have any effect on the adult grasshoppers because they don't really have any more molt to go. It's going to be most effective against the nymphal stages that still are going to be able to go molt, and then once they go to molt, they'll die in that molting process. And then lastly, permethrin is also an effective insecticide against grasshoppers. There's many different trade names. But like with any of these insecticides, they're going to be effective earlier in the season. Once you have the grasshoppers have invaded, there's very little that can be done to manage them with insecticides. A lot of these strategies that are outlined for grasshopper control with insecticides involve you spraying like every few days for a period of a few weeks, or it's essentially a continuous insecticide application regimen, which in my opinion is not very tenable or sustainable. Which brings me to my last slide here, which is, imagine I have this tree and it's clearly been not planted in the right place. It's growing where it's planted where its power lines are going into it, and it has created this perpetual maintenance item. I need to prune this tree every single year to prevent there being a problem. And I want you to apply this same principle to grasshopper management. Let's say that I have grasshoppers attacking my ornamental plants every single year. And so do I need to try to spray insecticides every single year perpetually? Those chemicals that are also posing a great threat to, your personal health as well as the threat of the environment, especially to aquatic systems. So rather than putting the wrong plant in the wrong place, maybe I should just plant things that aren't going to be vulnerable to grasshoppers. I should rely more on these lower tiers of IPM rather than the top. Um, yeah, because those insecticides are not without risk. Um, so I mean, I understand the use of insecticides for protecting our rangelands and our crop systems because literally producing food and us eating, I think, is more important than the aesthetic quality of the plants in our front yards. And without that, that's the end of my presentation. I'm happy to take questions or maybe give my extra time to Lisa or to Melissa.
Due to the high number of questions, we'll just continue on with our with Lisa and Melissa. Thank you, Kareem. I have been noting everyone's questions, so I promise we will get through the majority of them once we get through here. So hang tight. But I know there's lots of good questions in here. So Melissa or Lisa, you should be able to take control.
All right, give me just a second to get the PowerPoint going.
Perfect, and we can see you and hear you and see your slides.
Okay. Oops, and I gotta switch the view there. All right, looks good?
Yep, we're all good to go.
Okay, cool. Well, Thank you for having me today. Speak about grasshopper management. My name is Lisa Mason, and I'm a horticulture specialist with Colorado State University Extension in Arapahoe County, so the southeast South Denver area. Today I'm going to talk about grasshopper management through the lens of pollinator protection. And so I'm going to start off by talking about why we need pollinators and a little bit about their life cycles. We're going to dive into how the impacts that grasshoppers have had on beekeepers, and then if pesticides are necessary, what precautions can you take to help protect pollinators? And then I'll wrap up with a few final thoughts. But to dive right in, why should we care about this? Pollinators provide about 1/3 of our food source across the globe. So about 1 in every 3 bites of food. Bees alone can pollinate up to $15 billion worth of crops each year. And there's about 80 different crops that are somewhat to fully dependent on pollinators. And that includes our fruits, vegetables, and nuts. But the benefits of pollinators actually extend way beyond just pollinating our fruits and vegetables. One example is that pollinators will pollinate alfalfa and clover, which are food sources for our cattle. So our meat and dairy industries are also dependent on pollinators. And then from an ecosystem perspective, about 75% of the plants around the world are dependent on pollinators for plant reproduction. And if you're not sure what a pollinator is, or why, what's happening with that, basically in this graphic here, you're seeing a bee visit a flower for a pollen and nectar reward. And in that process, the pollen grains stick to her body. And when she flies to the next flower, those pollen grains are deposited inside that flower, and that facilitates plant reproduction. This could be a whole nother class in itself, but to give you an idea, that's what's going on with pollination. Pollinators you might see, whether you're in a rural area, agriculture area, or urban area, you're likely to see all of these pollinators in the landscape. Hummingbirds in Colorado are the primary bird pollinators. They have migrated south for now, and they'll be back next April. We have about 4 species you'll commonly see. Bees are among some of our most efficient pollinators because their bodies usually have a lot of hairs on them, and branched hairs where those pollen grains really stick to their bodies. Colorado has over 1,000 species of bees. So we're going to talk a little bit more about their life cycles here in a second. Wasps are also, not all species are pollinators, but there are many species that are. Wasps also are important because many will prey on pest insects. Flies, same thing. Flies are common flower visitors. The larval form of syrphid flies actually parasitize, or I'm sorry, they feed on soft-bodied insects. And there's some species of bee flies that will actually go after grasshoppers. So that, and we heard that from Dr. Shell earlier. So flies are double benefits. Butterflies in Colorado, we have over 270 species. And they're often welcome flower visitors. Moths, we have over 1,000 species here in Colorado. And while we do have some major pest moths in the state of Colorado, we also have a lot of beneficial pollinating moths as well. Beetles are also, they can be pollinators and predators of pests. And then, of course, bats. Bats do feed on a lot of insects here in Colorado. They pollinate plants if you go further south. And this is important to, this when we're treating for grasshoppers, we often think about honeybees. And in fact, most of the research on pesticide impacts on bees has been done on honeybees. But when we think about the bigger picture, over 1,000 species of bees, just in Colorado alone, we have about 4,000 in North America. We have to look at the other bee species. Where do they live? What are they foraging on? And so I want to highlight a couple of specialist relationships that we have. Bumblebees will do something called buzz pollination. And so when they land on a plant, they have a special vibration that releases that pollen from the plant. And so we actually have plants that require that, that buzz pollination, meaning no other bees can do that. Tomatoes, peppers, any of our nightshade vegetables, blueberries, which you won't find growing too much in Colorado, but in other parts of the country do require buzz pollination. If you grow squash or pumpkins, they're pollinated by squash bees, and those are ground nesting bees, which is something else we'll talk about in terms of pesticide application with grasshoppers. Only pollinators that pollinate squash and pumpkin plants. And something else to keep in mind too, all of our butterflies and moths have specific host plants that their caterpillars feed on. We have a lot of generalist beneficial insects. A lot of our bees are generalists, meaning they'll forage on a wide variety of plants. But butterflies and moths have those very specific host plants, and many of those host plants are found in our home gardens and in rural landscapes. And I want to touch on the life cycles real quick because when we talk about ground nesting bees versus honeybees, the management is very, very different. And so our primary eusocial bee in Colorado and North America is the honeybee. Those are typically going to live in human-made hives, and they're a managed and domesticated species. So when we talk about hive loss, that is important to note that that's not representing the entire population of bees. That is very hive loss has huge economic impacts, and it's devastating, but it doesn't represent the entire population of bees either. So important distinction there. Most of our bees are actually living and nesting underground. And so those female bees collect pollen and nectar, and they pack it into bee bread, and she will find her underground nest and lay an egg on that bee bread, seal up the nest cell, and she'll do that over and over again. So now that winter's almost here, her brood is protected underground, and they will emerge the following season. Here's some example of an underground nest and also cavity nests. So about 70% nest underground, 30% nest in cavities. Our bumblebees have a slightly different life cycle. They share social characteristics and also solitary characteristics. And the most important thing to note with bumblebees in terms of grasshopper management is those queen bumblebees hibernate in leaf debris and undisturbed land. So when we talk about disturbing the soil, something to be mindful of is we do have queen bumblebees hibernating. In the spring, she'll emerge, she'll start her colony. Her colony will run all season, and then the cycle will repeat. Okay, I'm going to switch gears a little bit and talk about beekeeping. So again, this is our domesticated our major species of bee that's domesticated and managed. It was a challenging year for beekeepers. Rural areas were probably much more heavily impacted than maybe some of our urban areas, simply because there was less floral resources. We started off the year with an Arctic blast in mid-January, and then we had a hot, hot, dry year. And the season has really extended. I mean, here we are, November 1st, and we've had, our freezing temperatures, at least on the Front Range, for the first time since last winter. So it has been a hot and dry year. In many parts of Colorado, we started seeing grasshoppers as early as February. So the grasshoppers are already munching on that plant material. When honeybees then emerge, when the weather gets warmer, they typically are active on days where the temperature is 50 degrees Fahrenheit or higher. So they're emerging and they're starting to ramp up their population. And when they're supposed to be ramping up, a lot of that plant material that they would normally forage on was already decimated by grasshoppers. And even the dandelions, in many parts, they didn't even have dandelions to forage on. Dandelions are better than nothing. They are not one of the most nutritious sources for our honeybees. They actually lack a lot of the amino acids that honeybees need. So they're great supplements, but they're not enough. But in this case, there weren't even dandelions available. And then, of course, a lot of the native floral resources were either low or non-existent. And they struggled. Beekeepers are still struggling to maintain healthy hives. Talking to Beth in Pueblo County, honey production is down 30 to 50% even. So the hive losses are high, and even the hives that are still here, they couldn't ramp up their numbers for a strong, healthy hive. This means they're more susceptible to weather fluctuations, pathogens, and varroa mites. Varroa mites are perhaps one of the biggest challenges facing honeybees right now. And with low population numbers in a hive, low honey reserves, mites are even more of a concern. Varroa mites also typically ramp up in the fall too, right before winter. A few other observations that I think are worth noting, and thank you to Beth for these. With the high numbers of grasshoppers, when those grasshoppers hop, a lot of times they're hitting the hive, and that is so prominent. It's actually agitating bees, and agitated bees are going to use more resources, more energy, which again just really isn't helping out those bees. And another interesting observation was in some grasshopper counts, activity of grasshoppers was actually heavier around the hive. We're not really sure why that is, but interesting to note. And so if you're a beekeeper, whether you're in a rural area or the Colorado Front Range, here's some tips to keep in mind. Supplementing the feed for your bees is going to be so important. General guidelines are in the springtime. You want to give those bees a strong start to the season. So you'll want to feed them about a 1-to-1 sugar to water ratio of syrup. And about March or any time when that sugar syrup isn't going to freeze, March is when they also start to build up their brood, their population. So give them a strong start. And you can feed as long as you want until you have that honey super on your hive. In the fall, you're going to switch the ratio a little bit. You're going to do a 2-to-1 sugar to water ratio of syrup. And this way, when it starts to get cold out, those bees need to save their energy and cluster around that queen for when cold temperatures really do arrive. So by feeding them in the fall, you're giving them a chance to focus on that rather than sending out those foragers looking for nectar that may or may not be available. And feed just not while that honey super is on the hive. And you'll want to also consider pollen patties to support the protein needs for those bees. When they don't get enough protein for their development, they actually turn out to be poor communicators, meaning they can't tell their sisters where all the good flowers are. And ultimately that can lead to low hive health, and maybe even that hive might not even make it. So you want to make sure that your bees are getting enough protein. So pollen patties are a great idea. And then also a water source for bees as well. And actually a water source for all beneficial insects is great. You want to make sure you keep that water fresh so it doesn't become mosquito breeding ground or anything like that. And if you want to know more about feeding your bees, I did include a QR code and a short link, so you can read more in a fact sheet about best practices for feeding your bees. Other things to consider, mite counts and mite treatment are more important now than ever. And really, by treating for mites, you're gonna hopefully ensure the survival through the winter. So there's a couple different ways you can do mite counts. If you have that threshold of about 6 mites per 300 bees, you're gonna want to treat for mites. There's a variety of options and a variety of opinions on which options are best. I recommend visiting the Honeybee Health Coalition. They have a varroa mite decision-making tool. They also weigh options, all pros and cons for mite treatments. And then, of course, monitor for other pathogens, pests, and things like that. I have 2 QR codes there for the Honeybee Health Coalition and also a publication from CSU on integrated hive management. Okay, let's talk a little bit about pollinators and pesticides. So if pesticides are necessary, and you heard from both Kareem and Scott, you've gotta, you want to use IPM and you want to weigh your options. If pesticides are needed, of course, you're going to want to choose the least toxic and less persistent pesticide to hopefully have less impact on pollinators. You're going to want to read the label very carefully and apply the directions exactly how they are on the label. This is federal law that you have to follow the directions according to the label, but it's also going to reduce the risk of impacts besides treating that pest. And you'll of course want to make targeted applications. One thing that's super important that we've talked about, treating pesticides when the grasshoppers are nymphs is critical. And then you're going to want to, if at all possible, you don't want to apply pesticides when the plants are flowering because that will kill not only bees, pollinators, and other beneficial insects. You want to be mindful of systemic pesticides in the soil as well because the plants will uptake that product. And if it flowers, those bees then are going to take those chemicals back to their hive. In general, dry granular formulations are going to be lower hazards to bees. So when we think about like the carbaryl baits, carbaryl is highly toxic to bees, but when you're applying it in that bait form on the ground, it's not on those flowering plants. And so generally it is considered to be lower hazard to bees, or dry, the dry granular formulations are generally considered to be lower hazards to bees. And again, you'll want to be mindful of those systemic insecticide. When we look at foliar sprays are higher risk just due to the direct contact of the pesticide on the plants and the pesticide residues as well. Some foliar sprays may persist longer than others, so you'll really want to consider those active ingredients. And then dust and microencapsulated formulas are some of the most hazardous to bees, especially because those dust particles will stick to the hairs of bees, and then they can take them back to their hive or back to their ground nest. So keep that in mind. And some general best practices. You're going to want to locate any honeybee hives nearby and take precautions. This is important to communicate with your neighbors. If your neighbors have hives and you're going to apply something that may impact their bees, give them a heads up so they can take precautions. One resource that is available is driftwatch.org. Beekeepers can document that they have hives, and so you can actually look at beekeepers nearby on the map, so you know who to contact if you're going to apply pesticides. Note, not all beekeepers are on here. It's an optional thing, but it can be a tool. You're going to want to prevent drift. So that's common sense. Don't spray when it's windy outside. And also be aware of other water sources. So puddles, bird baths. Keep in mind all beneficial insects are going to need to drink water. Butterflies will visit puddles for minerals. And they're going to look for small water sources. It's not going to always be, a big pond or anything. They're going to find the smallest, most accessible source of water. Consider applying pesticides when bees are not active. So 1 hour after sunset or 2 hours before sunrise are good options. But also keep in mind, if you're applying before sunrise, those squash bees are very active in the early morning. So if you have squash or pumpkin flowers blooming nearby, keep that in mind. And you want to be mindful of runoff. So do not apply pesticides if it's going to rain shortly after. Other things to consider, plants in your area. And this is a complicated one. Weeds are a great example. A lot of pollinators utilize weeds for pollen and nectar resources. And thistles comes to mind, attracts a wide variety of pollinators. Some caterpillars even host on thistles, like painted ladies. Not all thistles are the same either. This is why plant identification is important. We do have some noxious weeds like Canadian thistle, musk thistle. Great to remove those. And then we have a lot of native thistles that should be left alone. One thing, if you are considering removal of some of these plants, the pollinators do depend on those for nectar sources. So maybe think about what could be replaced to help support those pollinators. I mentioned, you got to choose the least toxic, less persistent pesticide when possible. If you want to know more about the different active ingredients of pesticides, the National Pesticide Information Center is a great resource. You can search by active ingredients and read all about the hazards or not hazards of that particular pesticide. All right, few other slides. Just some last thoughts. I mentioned that most of our bees nest underground. That's also where grasshoppers are laying eggs in the soil. And so, one option, if you have areas of undisturbed soil, just by disturbing that soil can kill a lot of grasshopper eggs. But that same process may also kill those native bee nest eggs as well. So what do you do? And then, queen bumblebees are going to hibernate in leaf debris. So there's no perfect solution for this. No tilling will likely save those ground nesting bee nests, and you won't disturb the weed seed bank. You could disrupt the ground cover, like with a rake, or just that surface level, to hopefully kill the grasshopper eggs, but maybe not harm the ground nesting bee, the ground nesting bees. It's not a perfect solution, but one thing, if you're walking your property, if you notice ground nesting bees are nesting in those areas, and often that looks like a bunch of holes in the ground, and there might be an aggregation. So you might see, 50 or hundreds of holes in the ground. Maybe leave that area alone. Don't disturb that area, but go to other areas on your property where the ground nesting bees are not nesting there. That's not a perfect science, and you really have to weigh the pros and cons too. But it's just something to be mindful of. Another phenomenon that we're seeing that's it's good to just be mindful of is when we have low floral resources, and grasshoppers are decimating the flowers. There's probably going to be higher competition between honeybees and native bees. There's a lot of variables that go into this, and different strategies are required for honeybee management and native bee management. But it is something to, keep in mind. So whether it's hive density, amount of floral resources in an area, we may start to see more competition between honeybees and native bees. And honeybees would generally outcompete wild bees, but honeybee populations are also struggling. So it's not good for anybody. But we do just have to be mindful of that and aware of different strategies to manage both. Some other thoughts. When you're doing grasshopper control, that's great. When possible, adding pollinator habitat can support not only pollinators, but other beneficial insects that might even prey on grasshoppers. Spiders, bee flies, robber flies, praying mantis, even some species of wasps, blister beetles, all those can contribute to helping to manage grasshoppers. And then, of course, the other predators that were mentioned earlier. So when possible, add that pollinator habitat. On agricultural lands, wildflower strips have proven through research to be a great addition to not only support the biodiversity in an area, but may even increase the yield in some crops, even honeybee pollinated crops. Making sure that you have floral resources from the early spring to the late fall to support those insects. All pollinators and beneficial insects need food, water, shelter, and space. And then we talked about those host plants for butterflies and moths. I know adding pollinator habitats when it might be just decimated by grasshoppers may not be feasible right now. But when you're thinking long term, this can go a long way. Hopefully, we won't have high numbers of grasshoppers every single year. So this can be a long-term strategy to support pollinators on your agricultural lands or even in urban gardens as well. And I'll pass the baton off to Melissa now. Thank you.
Thanks, Lisa. Melissa, we'll go ahead and get you geared up, and then we'll get to our questions right after that.
Okay, just confirm you can see my screen for me before I get started.
Yes, we can see it.
Okay, thanks for confirming that. So my name is Mel Schreiner. I serve as the area extension entomologist for the Tri-River area. I'll be talking about, it won't be split as black and white as urban and rural. I'm located in a rural area of Colorado. I'll share perspectives on how grasshoppers have been managed historically and some of the current challenges we've faced this year. But here's my information. Please feel free to reach out to me. I know there are a lot of questions around grasshoppers. I just ask that I'm given the grace to have some time to answer your emails since they'll be likely out of area. I serve 4 counties in Western Colorado. I do a fair amount of work out of area, so I will eventually be able to address your questions. But consider me a resource, especially if you live in the western half of Colorado. But this is the area I work across the state. It's called the Tri-River area, and we're a horticultural, historical ag producing area. We, from field corn to sweet corn to Palisade peaches, we're a famous agricultural region, historically and modern day. You can see the colored dots represent extension offices through Colorado State University across the state of Colorado, and we do our best to serve every county in Colorado. There are a few that lack those dots, as you can see, but are serviced by surrounding areas. But challenges that the community faces are, in general, extension is considered a resource to approach. Whether you can't cook your Thanksgiving turkey or you're not sure what weed you have out back or what pest is eating your fruit trees, extension is through our Morrill Act, named after an extension entomologist, I just found out, established land grant universities. So it helped to encourage folks to move to a new state back in the early 1900s if they knew there was a land grant institution investing in providing experts to help solve problems. But we're talking about orthopterans today, particularly acridiids or short-horned grasshoppers. So here are some of my illustrations. I just find these to be fascinating. Insects, Orthoptera, ortho meaning straight, ptera meaning winged. Some don't have wings at all. They're reduced or are just a vestigial structure at this point, but most of them are winged, can emerge in mass numbers. In the state of Colorado, we have around, it's probably a little bit more than this now described to science, but we have about 450 species. That's across the Western US. In Colorado, 75 common. Worldwide, there's about 24,000 orthopterans. So it's quite a big piece of the animal kingdom pie. If you really look at grasshoppers, they represent quite a bit. Melanoplis is the genus that historically has been, at least in our area of Western Colorado, really, really problematic. Another issue is that we have years, like we've seen in the 2024 season, that we have multiple species emerging and there is overlap. And in general, this graph was made by Robert Hammond, who was extension entomologist in Western Colorado for a long time. And this was his attempt to show that, they emerge at different times, and depending on weather events, this can select or deselect for big population emergences, just based on weather alone. No grasshoppers the same. I think this really, just looking at their egg pods, you can see how, evolution and biology crams as many eggs into that pod as possible, leading to densities per square foot anywhere from 3,000 per, 10,000 per square foot. So it's a numbers game. We're really challenged when weather is not in our favor. There is I'm not sure if we can call their behavior gregarious, but there does seem to be some communal feeding through this roosting behavior that I've observed in grasshoppers. They'll hang out, they'll put their feet up on their lazy boy chairs and open up a Coke, and they're stripping the epidermal cells off that plant and weakening the structural integrity of that plant. I studied CBD hemp and described some of the fauna associated with that in Colorado in grad school. And we saw one of the most devastating pests in especially CBD production, where each plant's valued at hundreds of dollars. The grasshoppers would strip the plant completely of its epidermis, and then it would dry out and the plant would lodge, crack over, and land on the ground. So lots of issues with obviously this feeding in high numbers. I'm not going to dwell on this. This has been touched, but folks, it's earlier than you think that you need to be out scouting for hoppers. Scott did an excellent job discussing the importance of scouting and monitoring, and I think we're still off thinking about the holidays or something, but we're not out looking for grasshoppers in February on these warm days. I think do yourselves a favor and try to start earlier. Set the reminder in your Google Calendar now to look early next season at what species may be the first to emerge. In general, I'll be going through some controls here, weather. I'm not going to be talking about natural enemies. I actually removed that last minute just since it's been covered today. But I hope to get through just to convince you, this audience, of, this is mainly selected by our weather patterns and climates in the American West. Whether you have, drought and a lack of biomass and foliage for grasshoppers to eat early on in the season, that can impact their populations, or maybe a significant amount of moisture and maybe a temperature drop that would cause freezing. But really, weather is driving this biology. I think rainfall is something we seem to lack in the arid Southwest in general, but moisture, of course, can generally aid in survival unless there's this massive temperature drop as well. So these are Whitney Cranshaw's photos, who's my graduate advisor in grad school, is a wonderful entomologist, retired now. But when we have a lot of moisture and the temperature drops, hoppers out there can freeze solid, and then we lack that population for the remainder of the year. I'm going to transition into talking about just some Colorado history. Federally backed spray programs or extension supported spray programs existed heavily throughout, I'd say, the 1980s through the early 2000s. In general, that has there's been a big shift. So really, up until about 2012, CSU Extension helped to facilitate spray programs in the state of Colorado. And they're really based on the movement away from big, broadcasted, broad spectrum spray programs. Extension's taken more of a step to support community members to be the organizers and the leaders of these spray campaigns. And it's doable. We're running a spray campaign for a different pest, for Japanese beetle, here in Mesa County, backed by the support of our fruit growing community. But we've had to work closely with local government, motivated by industry, to get this spray program off the ground. It's not just going to be that Extension can hone in on your county and your area and run it as a leader. However, Extension can support these efforts, and I'll be going through that shortly. I'm not going to cover rats. Historically, some of the examples to follow here are historical examples, and they did utilize the rats program. But in general, I'm really grateful Scott touched on this. But whether you're applying rats in these strips, the insecticide is stripped, you're spraying half the acreage. This can be done by plane. This can be done whether you rig up a tractor or some type of ATV. But just some examples in the past, in the early 2000s, Robert Hammond was behind some of these organized spray programs. 20,000 acres. That's not a small amount of acres to treat. You can see here this map was before they even were probably using ARC. But the red highlighted properties show that those were committed properties that said, in order for our livelihood and in order to take that last cutting of hay, we do want to be a part of this. And, there's a massive community effort that involves multiple partners, conservation districts, extension, motivated citizens. Another example, Gateway, this was less acreage, but they hired an aerial applicator to come in, and there was almost, complete cooperation of that community, and it was all motivated by a community member, even way back in the day in 2007. But historically speaking, we have a lot of ag remaining from our historical eras of production in Grand Junction and in the Tri-River area. We have fruit production that is a specialty crop system. It's existed for a long time here. We have the Palisade Insectary that's located out here. It's a one-of-a-kind facility in the United States with how it's funded. And it's just because tree fruit has existed here. And, today we've diversified our markets, and there's quite not necessarily down where I'm at in Grand Junction, but up in the North Fork Valley. I can't remember if I have a map here. I do. In red is our North Fork Valley. And there's a higher percentage of organic production. It's actually per capita some of the highest USDA organic certified land in the country, just per person, if you look at that analysis. So this has been an area, unfortunately, that we've also had high hopper pressure, and it has been a tremendous challenge for folks to not have cosmetic damage to their fruit. I mean, I've had producers call saying they have more than 50% loss. I think the highest was possibly 70% loss of sellable peaches in particular. So especially as an organic producer, there's a lot less options for you to fight these, the millions of hoppers. That pressure is just too great. One example, I think I learned about this from Whitney Cranshaw, but on smaller acreage, folks can do their best to incorporate poultry. There's even orchards in this organic area of Colorado, the North Fork Valley, that they're releasing chickens into their orchard to forage before the year concludes. And this could be done, this is more of a garden example in front of you, the famous chicken moat. But utilizing poultry, and especially an animal that scavenges for something like a grasshopper that's going to otherwise lay eggs, it's a really unique and I think important point to make. To end my presentation, I want to go through just how surveying and having accurate surveys and working with professionals can really lead to critical management success and the success of that management. In general, what now, what next? We've been blasting you with information all day. Thank you for your patience. I would talk to your neighbors now, especially knowing that this is going to be needing to be a community-wide effort. Map the committed properties ahead of time. I mean, these months, I would do it sooner, actually. I should have changed those to probably the winter time. You should be spending a lot of time meeting with your community, with your Board of County Commissioners, go in to a public hearing and speak for your 3 minutes. As a Colorado citizen or a citizen of that county, you're able to speak to your Board of County Commissioners and tell them of your concerns. I feel folks do not do this enough. It does take dedicated time, but you are a citizen, voice your opinions on how this is impacting you. Scouting and being aware of egg hatch times. I know everyone wants to know what county, when do I do this? A lot of that is going to be decided by you when you go out and survey and get that data yourself and ground truth that information. I can tell you the month of March, May, it could be different in your county. So to ground truth, that's critically important. Prepare for, if you're going to go with a RATS program in a rural area, definitely approach what aerial applicators exist in that area. They're few and far between these days. Community involvement, having community meetings, be prepared for opposite viewpoints, especially with insecticide use. More than ever these days, there is a fear of pesticide application. However, having discussions with opposite viewpoints are more important than ever. So finding a consensus, you're all showing up because you're being impacted by a problem. What is the way to a solution? Working with your neighbors to do so is the way through this. Make sure you keep track, get people's emails, and put certain people in charge of a committee of some kind. In my opinion, that seems to be the most successful route. Having a grasshopper committee, so asking that someone in the community to step up and help to organize efforts, likely working closely with your extension agent in the area. But really dividing the area that is being impacted into sections or into quadrants has been successful. I've coupled with Routt County Extension Agent Todd Hagenboo up in Routt County to divide up their area of the Steamboat Springs area where they have, a tremendous amount of grasshoppers. It's an issue. Otherwise, if they do not manage, they cannot cut hay in that county. So going through this process is lengthy. It is maybe not what you want to hear because there's not a simple solution. So getting your community together so that you're not alone is critical, so that you can put this plan together and to do so well in advance. So sending letters to homeowners, indicating, of course, that, gaining consent and doing things legally is critically important. So keep yourself organized. Success of grasshopper control is really area wide. So start planning early, dictate who is in charge, apply these controls at the right time to suppress this biology, especially if we're using like the best tools in the book, IGRs or Demolin, something that's going to stop that growth process in that hopper population, and looking into the other details of making applications with pesticides. But success, we have very particular examples that this can be successful, but with unlimited funds and complete landowner cooperation. This is a direct quote from Bob Hammond. I mean, truthfully, homeowner cooperation and differing viewpoints tends to be the thing that can sink the ship on some of these community organized efforts. So I want to thank Whitney Cranshaw and Bob Hammond. Their education and time with me as I've become the extension entomologist out here in Western Colorado has been critical. So thank you for your time.
Perfect. Well, thank you to all of our presenters. I know there's been a lot of information and we have a lot of questions. We have about 10 minutes to get through. We're going to get through as much of them as we can. I'm going to pick on some of the presenters for some specific questions I kind of picked out. For those of you that were watching, I did get every question you asked. I did write it down. We will make sure it does get answered, and you will have more of that information in your email. So if your particular question doesn't get answered, I promise you we will get to it, even if it's not during this particular webinar. So with that, Dr. Shell, there was a lot of questions your way, but some of them wanted your opinion on some of the larger pesticide applications. So one of them was, what is your view on using, and I apologize, I'm going to mispronounce it, triazide? It's TRIAZICIDE. And is it worth it? Is it safe for using in smaller applications?
I'm not real familiar with the active ingredient in that product. And what is that in relationship to crop areas? I kind of thought that was a product sold in box stores and stuff like that, kind of a broad spectrum type of product. But I'm not real familiar with it. What I generally recommend for, say like my friend in Nebraska who's having his orchard chewed up, I recommended permethrin. Permethrin is a synthetic pyrethroid that has hot foot repellency. Like Mel I think it was Mel pointed out about the grasshoppers roosting on the plant and chewing off the bark essentially on these trees. You don't want to use something that they just eat their fill and fall over and die. And then you want something that they'll get up on there and say, ooh, this is uncomfortable, and get off. And so when I'm asked, if they're going to utilize an insecticide, I recommend the permethrin active ingredient products. They have broad labeling and can work as a repellent.
Perfect, thank you. And then this one was asked a couple times in a different format, so I'll open it to any of the panelists if you would like to share your thoughts, are there specific protocols for organic producers from like baits, sprays, things like that? Like, are there things that you all are aware of that would work for organic production, whether it be a home garden or a larger scale?
Well, I'll take a stab at it. Pyrethrum is the organic form, and can be utilized in the same way as permethrin. It has a shorter residual, and it you might have to apply it more frequently. There are some of the pathogens that have potential, but you have to look at the carrier of the pathogen to make sure it is also OMRI certified. So that can be an option. And of course, the tillage or physical control types of things are suited also for organic.
Yeah, I agree with Scott. It's well said. I mean, as an organic producer, you're going to have to rely more on non-chemical controls. I mean, there are some, as he suggested, some of these biopesticides that were discussed today, BT, Beauveria bassiana, Nosema locusti. I didn't have quite the time to discuss Nosema locusti, but without a local source, and we're likely not to get another one anytime soon, just due to the challenges in producing Nosema locusti. Either way, it's not going to be full control. You are going to have to lean into some of these other tools in your toolbox as an organic producer, maybe considering treating outside of your organic land. Can you convince your neighbors to control certain abandoned lots, or what can you do? Can you border control or not? Everyone's situation is different. And unfortunately, as an organic producer, you do not have many options. And I do think it's worth putting that out there. It limits you in an incredible way, unfortunately.
I agree. One other thing I noticed when I was reading the questions, there was a question about neem. So neem is derived from neem tree leaves, and it can be an oil with an active ingredient called azadirachtin, or the azadirachtin can be extracted from that oil. We did experiments on grasshopper repellency, and azadirachtin does work. It is a feeding deterrent to grasshoppers, and it can be obtained as organic. It breaks down very rapidly. You have to apply it frequently to the plants that you're protecting. And I don't know whether that would be plausible labor costs or treatment costs, but that could be another option too. So it's a difficult situation.
Perfect. Thank you all. Really quick, just a few more questions here, and then I promise we will end this, and then all those other questions will get answered. Kareem, a few people wanted to know do you know, does the Palisade insectary have the listed biological controls that you talked about, or are other CSU entomologists, do you know if they are available there at the insecticidy?
I'm not aware of the Palisade insectary producing grasshopper biocontrol. They focus a lot on weed biocontrol, like bindweed mite. The Canada thistle weevil hasn't been offered this year, but not really much. They have like a few insect controls, I think, for peach pests, but not really for grasshoppers at all.
Yeah, I'll add to that since I'm right up the road. I could throw a rock and practically hit them. I would say Kareem's dead on. They don't, unfortunately, focus exactly in those areas, but that does not mean that these biocontrol agents are not available to you. So commercial insectaries exist in private industry all over the U.S. Arbico Organics, I'm trying to think of a few off the top of my head, and I'm going to be poor at that, of course, but there's several. And yes, thank you. And you can buy those through other means, essentially. Some of these biocontrol agents, I would say Nosema locusti is not one you can access. And I question the efficacy of Nosema locusti anyway, based on the lack of just efficacy data showing it really works as well as people say it does. However, some of these will be harder to find than others. Things like BT and Beauveria bassiana. I mean, there's many products that have known trade names that you can access these, biopesticides versus maybe a biocontrol where you're actually trying to bring in like nematodes. So I actually don't know a great source for nematodes. I just want to throw out there that UV light is really going to degrade those. Lack of moisture, you're likely guaranteed to have to try again to get nematodes to work, especially in the arid West. But yeah, commercial insectaries would be something that we can try to send out in our list of resources. I can provide some of those to Beth.
Perfect, thank you. And then we have one question for Lisa, and then just a general one last big one. So Lisa, they wanted to know, are garlic oil and neem oil, when used as a foliar application, are they safe for bees? And if not, are there precautions that could be taken if they're still trying to use those with bees?
Let me check on that. Unless someone knows that off the top of their head. Does anyone know that off the
I
top of
know
their
the neem oil is pretty toxic to bees. You do want to avoid spraying that when they're most active out of the hive. Garlic oil, I've not heard of anything from that, but neem oil can be very toxic if sprayed when they're actively moving around during the day.
We,
I can
we
check on garlic too while we do the general question.
We tested garlic barrier, a product that actually had grasshoppers on the label, and hot pepper wax as repellents, and they failed in the lab and in the field. My conclusion was grasshoppers like their food hot and spicy.
Good to know. Okay, our last general question that was asked in a couple different ways, and all of you are welcome to add in different inputs if you would like, is if there's someone that has smaller acreage, we're talking like a couple acres with an ungraced field or land that maybe has been unmaintained for a couple years, is it worth mowing it or trying to do like a trap zone, or what should they really do to try to manage some of those larger areas that just really aren't either being grazed or like highly maintained?
Well, I'll chime in. It can be helpful. Essentially, you think of a field like it's full of yellow sweet clover. That's a magnet to the two-stripe grasshopper, and you can have tremendous populations come from there. And so, if you mow it, yeah, it will help the grasshoppers. Now, it will be a negative to your pollinators and honeybees and things like that because it won't have it available. But it'll reduce when you get those really rank growths, it's of weeds where it's full of grasshoppers. It's three-dimensional. If you mow it and you still have grasshoppers moving into your yard and garden, you can maybe treat with bait more effectively and get them. So yeah, I would say that would you have to wait. There is some negative. It's not all negatives to good beneficial insects come from insecticides. Some of the cultural controls can have problems too.
Perfect. Okay. So I want to thank all of you for joining today, for taking your time. I know it was a lot of good information, but we will take all that time to digest. Again, for all of you that are watching, this is recorded. I will have a lot more of in-depth information along with the contact information for all of the speakers for you to reach out and ask further questions besides what we kind of covered during the webinar and the ones that we recorded during it as well. So with that, thank you all again for joining. Again, it will be live about midweek, so please look for either an email from me directly from Beth, or you can just go onto the Pueblo County YouTube channel page on Wednesday, and it should pop up as the video will be public, and you can watch it, pause it as many times as you would like. So again, thank you all. Speakers, if you have like any last thoughts, you're welcome to throw them in there. If not, we'll call it for today. Thank you so much.
You're welcome.
Perfect. Well, you all have a great rest of your day, and look for that recording and all of the information to come via email. Thank you all.
Cool. Thanks, Beth.